Thank you so much. I will take first the privilege of the moderator to make some introduction. Then I promise I will hand over to our panelists who are much more interesting than I am. We'll be talking about interoperability and federation in the data ecosystem. Today in the morning, I spent a couple hours discussing a very, very similar questions around cloud and infrastructure. These two are heavily interconnected and both are experiencing rapid changes. In the data world, I believe that we are looking at, one could say, a perfect storm for us here, because on one hand, the volume of new data that is being produced seems to be rapidly increasing due to, well, increased cadence of launches, due to lowered price of launching mass to the Earth orbit. We have more and more synthetic data as well from simulations. On the other hand, we seem to have access to really outstanding tools to analyze that data, to interact with that data. And I am talking about large AI models, not only language models, or also models that deal with other modalities. And before we go into questions, I would ask our panelists to once again introduce themselves. But in that introduction, please tell us in one brief sentence with what kind of data you're currently working, what is most important for you in that context. Let's start with Leandro.
Thank you. It's an honor to be here, participating of the panel. So my name is Leandro Parente. I'm a researcher at OpenGeo Hub. So my background is in computer science, and I'm working with Earth observation data for a while. So I mostly work with the land cover monitoring, so like spectral data, so Sentinel-2 images. But we also work with Landsat and MODIS, different satellites. And we basically try to use this raw data to do some mapping products to support different stakeholders and insights.
Thanks. My name is Stefan Siemen. Also happy to be here and join the panel. I'm from ECMWF, the European Center for Medium Range Weather Forecasts. I'm the Strategic Projects Coordinator. So, as you might know, ECMWF has a lot of activities involved, not just the core weather forecasting ECMWF does, but also Destination Earth, Copernicus, different programs. So I'm trying to help to coordinate these kind of activities and have been quite involved over the last years with Destination Earth.
I'm Marina Tonani from Mercator Sun International. Mercator is the entrusted authority for coordinating the Copernicus Marine Service, but is also coordinating the project EDITO for the development of the European Digital Twin Ocean. So my focus is really at sea, on the ocean. I'm really not an expert on the land, and we are looking into all the possible information that we can gather on the ocean, and the satellites and remote sensing is key, and we are really using and exploiting this information for the ocean.
Hi everyone, my name is Maxime Lamar. I'm working for a company called Synergize, who's part of the consortium which is building the Copernicus Data Space Ecosystem. So I'm a little bit on the other side of the data. I'm not a consumer, but more on the producer side. At the moment, we're putting a lot of effort in integrating the Copernicus Land Monitoring Service data from EEA and JRC into the platform. So I'd say that's something that I work with on a daily basis now. And then mainly working with the Copernicus data, so the Sentinels.
Thanks a lot. Okay, let's get to it. European data ecosystem and data landscape is very complex, and I would ask you to explain to everyone and to me as well how do you understand it, and how do you understand your role, your organizations, and your projects and platforms' role in it. I would start with you, Maxime. What is the role of CDSE as one of the biggest platforms that we have?
So just for context, CDSE is a DG DEFIS and ESA initiative. It's funded by the European Commission, and the goal is to provide the data and services that are linked to the Copernicus program. So the most common one is the Sentinel data, particularly Sentinel-2, which is one of the most used Earth observation platforms at the moment, but also all the added value services on top of it. So if you look at CDSE, if you remember the pain it was to work with Sci-Hub when you had to download or access the data, we've gone a long way since that time, which was about 4 years ago now. And CDSE is there to offer the access to the data. But that's only one part of the story, right? Sentinels being one of the most widely used sources of Earth observation to date. We provide the visualization of the data and the downloading, but the platform also provides the tools to work with the data. And I think that's a big change in paradigm from what we were used to, platforms where you actually just access the data and download them. So we offer a set of APIs that allow the access to the data to work in the cloud next to the data, but also tools where you can collaborate, share what you've been building on top of the data. And I was looking at the numbers just now, and Copernicus Data Space Ecosystem hosts over 90 petabytes of data. And today we reach 700,000 users registered to the platform. So I think we can see it as a backbone of the European EO landscape.
Okay, thanks. So we have CDSE as this big pillar that supports the center of the ecosystem. We know that there are multiple other elements. Marina, how does Digital Twin Ocean, how what you do fits into that picture?
Yeah, so the Digital Twin Ocean initiative started building upon two main European assets for marine observation and marine information. So they are IMORNet for all the in situ data that are related to different thematic for the marine environment and the ocean in general, and the Copernicus Marine Service that is providing information that are based on satellite and in situ, but also on models for the past, and also projecting in a forecast for the future. And based on these two assets, with the DTO, what we have developed is a common access and harmonized access for these two key sources of marine information in a cloud-optimized environment. So this speed up the access to this data and also make it more flexible, the use of the data, because you can just select what you need when you need. And together with this, we offer also computational capabilities so that the users can develop tools, models, use AI, so that they can really generate the information that they need. And this, of course, is increasing the layers of knowledge that we can have for the marine ecosystem. And we are aiming to be able to address all the different components, including biology, socio-ecology, socio-economy, so that we can really understand how we can better manage and protect the ocean, understanding what is the impact of the decision that we can make. So we are offering a decision-making tool that is able to address the needs of, in particular, the ocean and the marine community.
So do you see yourself primarily as a data producer or a consumer?
That is a very good question, because I think that we cannot choose between the two. We cannot pick one because we are both. Because in terms of a digital twin of the ocean, we are a consumer of all the data that are provided, for example, from Copernicus Marine and IMODNET, but at the same time, DTO is generating new data and is adding layers of information. And I don't think that there is a priority between the two, and yes, both.
Thank you so much. So we have CDSE, we have digital twins, now, and we have Destination Earth that connects digital twins and that connects them with infrastructure. And I think nobody is better suited to tell us what is the position and what is the role, what is the idea and the goal of Destination Earth in this context of the data landscape.
Yeah. So Destination Earth as a target is to also, like the digital twin of the ocean, to enable more precise and better informed decision-making tools and processes. So you will have heard that we have 2 digital twins on a global scale, on very high resolution, groundbreaking high resolution, the extreme weather twin, and then also the climate adaptation twin. So this is something, data sets of quality we have not seen before, but also of size we have not seen before. And here's really, how do we now provide ways to make decision making? So Destination Earth has, prediction scenarios on a global scale, but what we're actually looking at the end product is local decision making. And local decision making will not be just done by knowing the climate situation in 20 years' time. You need a lot of more information, and it's so key that we build an ecosystem on which these kind of decision-making tools can be built. They will not be built within Destination Earth. It will be the platform on which these global data sets can be accessed, and then the public sector and private sector together can build local decision-making tool, like for example, look at Brussels. If you want to build a local decision-making tool, this is not something which can be done on a global scale. You will need to work with local data sets, local partners, have local requirements, but we kind of want to facilitate how we can make these large data sets available for these local decision makers. So that's a big drive for us. Global projection, big data sets, but the user will want to work on a local scale, and that we need to support. And that is why I'm just coming from the Destination User Exchange here in Brussels the last 2 days, and it's so important now, working with a lot of partners, especially also in industry, how we now can get the next step now that we can build these kind of use cases, but then also application directly with local decision makers. Yeah.
Thank you. Okay, so we have a bit of a landscape painted by you. I'm very grateful for that. It's important to be aware that there are many more stakeholders in this landscape: Copernicus services, national data platforms such as CODDA, or national satellite constellations. So many more stakeholders. They synergize with each other. They use each other's data. They cooperate. And everybody is talking about federation. So before we talk what we need to do to federate, I would like to ask you, Leandro, how do you define federation? What does it mean for you? I see you as a user of these different assets, data, and resources. So how do you understand a federation, how the federation looks like, ultimately how it should look like in the future?
Okay, that's a broad question, and thank you. And so for me, you are totally right. Everyone is talking about federation. And I think it's important to also think on the user perspective. So when you think about federation, it's basically like different systems communicating and sharing data and sharing messages and having like common standards and protocols. But from the user perspective, it's important that the user is aware that he's entering in a federated system, because this manages the user identity and the user data in a different way, because the federation will somehow kind of share access tokens, and the data of the user will live in a different way inside of a federated system. But on the user experience side, on the, I mean, when the user needs to run analytics for Earth observation data on a federated system, this should be seamless, right? So the user should be able to integrate massive Earth observation archives in a very easy way, and it's very tricky and difficult to implement, right? So let's give an example. Imagine that we would like to run an analysis and compare the Sentinel-3 land surface temperature, that it's a massive archive, right? Like we have a lot of petabytes, and this is stored currently in different locations, but in Cloudflare. And we want to compare this with the ERA 5, the land surface temperature ERA 5, that it's in ECMWF data centers, right? So right now, this data is not really integrated in the CDC, but they have like protocols, they have data formats that you can easily integrate and connect these two data sets, for example, to compare the land surface temperature for any European city, for example, or in any place in the world, because these archives are global. So it's really important to have data protocols and these massive infrastructures. They need to be able to communicate each other. And the backbone to make this happen is open source solutions, because you need to have the same standards, the same protocols, and in some cases even the same software to make this work in a proper and in an operational way.
Stefan, you have been called out with ERA 5. I do not even need to ask the question, but I will. So, when you listen to Leandro, what has out of these asks Destination Earth has delivered? What it should deliver on top, in your opinion?
Okay, so Destination Earth, we're now in the just finishing the second phase out of 3 of the build-up and everything. So what we have delivered is what I mentioned at the beginning, the global digital twins. They're running now, they're operationalized. That means the first time we can really done climate scenarios now on demand and continuously on when they're required in the future. So this is really a breakthrough. This has been put in place. So the second phase, we started now working through dedicated use cases to demonstrate the benefits. And now we're looking at how we're now bringing forward and allowing users more to get these data sets together, because it's really about as was just mentioned, I mean, to get these different data sets together as a decision maker, you're not relying, it's the days where you have just your specific data set and make decisions are over. Now you're combining a lot of different data sets from different sectors, different backgrounds, and you need to keep trace of it, because decision makers need also to know where the decision comes from. This will be especially a challenge now with AI, because you need to have the accountability and the traceable transparency of how you make the decision. So there's a lot more than just throwing data out through APIs. There's also, we need to think about that, the long-term sustainability. So I think that it's for us as a data provider from key data sets like ERA 5 and in future ERA 6, there is a lot of work also to help and assist all these kind of work, have these APIs, interfaces ready. We're knowing also now that AI challenges us on traditional data formats, how data is stored, all that needs to be answered to, but we're not just throwing old workflows away. We need to still support them and also be flexible for the future. So it's an interesting time, but it's also challenging.
Maxime, Leandro mentioned that it would be great for users to use the same software across different platforms. What's your take on it? How it can be achieved, or how this seamless experience can be achieved? Not only seamless in identity and creating accounts, but really seamless in how you interact with the data. What's your opinion?
Well, before I answer that, I wanted to say I'm delighted to have Stephen on the panel with me, because when I talk to the users, And in all the projects I've been, the #1 source of data that's missing in the CDSE is usually Era 5 or weather data. So there we really need some interoperability. But to come back to your question, there's an analogy that I quite like, which is the pyramid versus the bazaar. So you can either build a huge monolith, a pyramid, and put all your investments there, and that's your unique source. Or you can go to the bazaar and go through the different providers, which is what the ecosystem looks like right now, and pick what you need. But for that, you need to speak the same language. And that's, for me, the critical point today, because we have protocols that are agreed on paper. We have initiatives that enable good interoperability, like Stack, or if some of you have heard of OpenEO, which is this API that abstracts the backend where the data is coming from. On paper, it works, but if you look at the reality, it's a little bit more complicated, right? So the hard part there is agreeing on the standards. You can have different platforms that have Stack implemented, but they still don't work together because they don't have the same extensions. And then, similar to the country I live in, Austria, then you end up with dozens of dialects and no one understands each other anymore. So there you really want something that people can communicate with the same protocols, and that's where we need to invest. And I'd say maybe the second challenge is the identification. So as a user, you don't want to have 10 accounts with 10 billing systems and 10 different services. So there's really some effort that needs to be put in place to unify these access protocols to have a seamless integration between the different data sources.
But, so that's a question to all of you. Would you say that today we have agreed on common standards, or there is still work to be done? I understand that implementation-wise there are differences, but do we have common standards? How does it look like, Marina, from your perspective? Your perspective, you mentioned that you're both consuming the data and you're producing the data, so you have to manage quite a lot of standards in terms of APIs and data formats. Yeah.
So yes, we have standards, and we are using, for example, for all the Copernicus marine service data, we are compliant with the CF Convention, that is the Climate Forecast Convention, and we are also sharing standard metadata that we are enforcing with international community in the frame of at least 2 UN Decade program, that is the Ocean Data Sharing and Ocean Prediction, so that we can ensure that what we are doing here in Europe in our service is really interoperable worldwide. And every time we are adding new variables and new products in our system, we are working with this international community so that we can agree on standards since the very beginning, that this is, of course, make our life easier. But it's also true that dealing with the ocean, we are encompassing several different communities, and I can guarantee that if you are working with satellite sea surface temperature, you are dealing with a community that is using standards that are very different from the community that is dealing with biology and ecological information related to the sea. And I think that here there is a challenge because we need to be flexible in standards and understand the needs of each community and have adaptable standard. That sounds like a contradiction, but we need to have standards that do not force the information to be shaped in a way that is not the right one. So we need to accept where is needed, to have different standards, and then to find a way to have APIs that can make these different standards communicate to each other. And I think that this is really something challenging because all this community are now much more exposed to have a quick exchange And that is what, for example, we are trying to achieve with the Digital Twin Ocean, where we go from data linking from biodiversity to data that comes from satellite sensors. So it's really key to be able to succeed in this for being able to produce tools that are really going in the direction that you can make decisions using it, and that everything can work seamlessly together for being able to be used by tools and for machine-to-machine exchange.
So I would like to go deeper into this topic of standards because I have two contradicting examples from other industries. In the telco world, they were able to meet and establish standards to cooperate. However, in the cloud industry, we have standards, but those standards were not pre-agreed upon by a committee of cloud providers, but the standards are de facto standards because everybody just uses that type of standard. What way do you see for us in our EO and EO remote sensing and scientific world in Europe? Stefan, would you?
I think it's, we have, as sectors, meteorology, weather forecasting has standards even going back to the 50s, which are perfect to send millions of data sets across the world in minutes, but they're not good for users to do data analysis on a local scale. So I think we're not the only sector who has well-established standards which work very well, but for a different purpose to what users need. And when looking at ECMWF, Copernicus, and especially also Destination Earth, when Connect started, it was not just for us exercises to create even more data, it is also to start interacting more with other sectors, industries, learning, and we're definitely not there yet, but I can tell you from 15, 20 years ago, we're definitely better than then. And this is actually why we need these programs, a lot of the projects, because you need to really sit down and explore what makes sense, sit with users, because to just sit in a room, do a paper exercise, what to deliver, we will not get the users. We need to really sit down. That's why, for example, in Destiny, it's really important to have the use cases to see how the data will be used, how the different sectors speak, because I think the language is, it's so interesting. And I mean, we also observed to just have a specific standard or convention does not mean it solves the problem, because you find a lot of little local adaptations and stuff, and we also use ourselves. So it's something we're learning the hard way, but it's getting better. And if you have it, we are so keen to make weather, climate data more approachable and used. So please get in contact, and we will really try to engage on this one.
Yeah, I also agree that we have standards, even like for Earth observation and also like geographical information systems. So when I started working with the GIS and remote sensing, so I was more on the side of the web development. So I was doing like web map applications and like building dashboards to show, for example, population for cities and specific vector data. So at that time, we had also like a lot of standards defined by the OGC, the Open Geospatial Consortium. It was working more in a kind of a centralized way, right? They were defining the standards first, and later you had like players implementing it. But I think a key difference now is we have basically this kind of a de facto standards, as you were describing, so the spatial temporal axis catalogs. But I would say also we have standards for really cloud native data formats, right? Because we need to have kind of more cutting edge standards that really allow us to move these data, these massive archives of Earth observation data across different platforms, right? Because in the way that, for example, the OGC was doing standards like 10, 15 years ago, even 20 years ago, it was really kind of a centralized. They have a kind of a endpoint or some middleware or some software solution that was doing the translation. But this doesn't work when you have massive archives. So another example is the ERA5 data, right? So right now, I was just checking before the talk, we have this in the destination Earth, you have the platform to, I think it's Earth Hub, that actually converted all the ERA5 data, the hourly data, in a ZAR file. So you have a single file where you can carry anytime, anywhere in the world, you can just go say, give me the ERA5 data for this specific coordinate. And this works quite well because it's really, you have a foundation that is a strong cloud-native format that gives all this possibility, and it's quite scalable. So I think this, we are seeing this shift that we have more standards now that are actually properly designed to address these massive archives that we have for Earth observation data.
Just quickly to add, yes, we are exploring a lot, but I can tell you also that we get also comments saying, oh, could you do the ZAR slightly different setup and tuned for our access? So it's still a learning curve, and again, one standard does not solve all the problems. Yeah.
And I think on this we have also a concrete example in the Copernicus Marine Service, because we are using ZAR too, and we are using ZAR for all the gridded data that we have, but then it's not efficient for the sparse in situ observations, and so for that we are using Parquet or we are using SQLite, so we had to find a tailored solution that was really the best for addressing a different type of observation. And I think this is key for being efficient. Then it means that anyhow you need to be able to address both and to make them easy accessible to the users and to have interfaces like our catalog and our viewer are dealing seamlessly with both. So from the user point of view, they don't see it, but we need to take this into consideration for being efficient.
And maybe on that note, speaking of SARS, conventions evolve as well, because at Synergize with Sentinel Hub, we support the ZAR v2, and now ZAR v3 is coming out, and we have to then adapt all our systems and look at the new functionalities and the new conventions. So there's also this component of always keeping up with how things evolve.
Yeah, in meteorology we had every 20 years standard changes. Now, every day you look your news, you find there's a new standard, new hit on the block.
Well, I'm not needed apparently. Okay, no, I'm very happy to listen to this discussion. So we have federation, we have interoperability, we have discussed the standards. In the beginning, we have painted the landscape, but it's not the goal itself. The goal is to generate value, either scientific or social or business. And my question to you is twofold. On one hand, I would ask you to give examples of success stories where this value is being actively created, where this impact of the investment, of the public investment, of effort, of thought of so many people goes in. On the other hand, what we should do to enable even more of that value. And I would like to start with you, Leandro.
Okay. That's a very good question, and I fully agree. I was talking today during the coffee break that it's like we have standards, we have the data, and it's, I think the last bit that is missing for several areas is really reach the end user that will have some insight with that. With the Earth observation data and with all these platforms that we have available. And yeah, to be honest, I don't have like a solution of how we can actually achieve that, but I can share one of the experiences that we are doing at OpenGeo Hub, that we have a project that is funded by the Global Methane Hub, where we are basically using Sentinel-2 data to derive grassland biomass. And of course, they want to use this data to support some actions on the ground. So they have 8 target countries in the tropical area: Brazil, Uruguay, Uganda, Zimbabwe, and more 4, mostly Africa and South America. And they want to use this data to provide insights for livestock and grazing management, right? So they want to use the Sentinel data to informed decisions on the ground. And that's a very nice goal. And yeah, we are working for a while with that, so we have a prototype. But now we are in the phase that we want to show and check if this data is making sense for people that are on the ground. So we have our Brazilian colleagues that are part of the project. They visited like a rancher, like several ranchers actually in Brazil. And it was very nice to see when we started explaining the project, everything was abstract, and in the beginning they were a bit skeptical. But once we showed the monthly curve of the grassland biomass for their farm and their paddocks, they were very interested. This immediately dragged their attention and say, okay, this data makes sense, because this immediately connects with the reality that they see on the ground. They could see that the biomass increase when you have more precipitation. They know when the precipitation happens. They know that when the precipitation stops, the biomass decreases. So what happens is, once we showed this to them, we received so many feedbacks. They said, no, we don't need daily data. We don't want to check this data to see if we'll move our cattle from A to B. What we want, it's actually that you give this data to us, but if you do some projection and say, if you have a La Niña that will be more strong, I will have less biomass, and that will affect my farm, right? So I think part of the process to make this data usable is really reach the user, but have this feedback loop, and that's not an easy process. It requires several iterations, and sometimes needs to be very targeted. Otherwise, if you just try to broadly solve different solutions and tackle different stakeholders at once, might not work. So I think that's probably one way to go to really boost the usability and make this data more actionable on the ground.
Thank you. Same question carries over. Success stories and what we need to do to have more of them.
I mean, success story, when you look Copernicus era 5, I mean, it's so used widely. It was a big learning curve. It was actually really nice to see how it has been picked up, and that we get a lot of question on, sometimes also critique, is because it's used and it helps us to improve for the future. So a lot of lessons learned for era 6 coming up, and these are the things we need to look at. And for us, very important is that with Destination Earth, looking now into the future with climate scenarios, we're trying to do a lot of the same standards, convention, so that a user who has familiarized himself with the Copernicus era 5, era 6, can also then take these kind of tools and could also then do it on future projections. So we want to really make it seamlessly, harder to say than what it's also harder to implement. But we want to see it from the past, future, present. So for example, if you write something to make a decision on a specific weather situation, you can test it in the past, see how it works today, and you can see how it will look in 20 years' time, what kind of thing. So this is kind of our vision to make that more seamless. But yeah, we already said there's no golden standard yet, and we will still learn a lot on the way.
So from the point of view of EDITO, so the European Digital Twin Ocean, we are not operational yet, but we are working in co-construction with several other European research projects so that we can develop a prototype. And I think that's a successful story, an interesting one. So we just finished a panel here about the Arctic, and it's well connected. It's about iceberg and how you can use the digital twin ocean for predict the movement of the iceberg and avoid collision when you are navigating in the Arctic. And this is an example where you are interconnecting information that are coming from different sources, because First of all, you need to look at satellite images for detecting where are the icebergs and understand if in the area where you are navigating you have icebergs. So you have iceberg today, so the day that you are there. So everything needs to happen in real time. Then, if you detect an iceberg that is in a probable, it could be in a collision with your route, has been developed and deployed on a DTO, a module that can predict the trajectory of the iceberg. And for doing so, needs to have the wind. So we have to go to our friends and get the winds. And everything needs to happen in real time because otherwise you have already crashed before. you know that you could be in a dangerous situation. You need also the currents, the ocean currents, and so it means that you need this information from the Copernicus Marine Service that is providing this forecast together with the information of the wave because also they play an important role. And thanks to DTO, you can tailor the information for you. So you can just run this simulation for the trajectory of the iceberg that is close to where you are navigating. And this can help you to better plan and to take remediation decision if it is needed. And I think that all this is possible in real time, simply if you can interoperate all this chain of information in a very efficient way and fast enough that you can have the information of your trajectory in a matter of few minutes from when you detect and you get the information that an iceberg is close to the area where you are navigating. And I think this is an example of how it could be powerful to have interoperable data and interoperable tools that you can use together with the workflow that you need for addressing a specific problem and really provide an answer in a matter of such a short time that will be useful and will change the decision that you can make in real time.
I think from CDSE we have it a bit easier because we're not stuck to one single vertical, but we span across a wide range of applications. That being said, when I said that we had 700,000 registered users, I think a very small portion of those are actually building solutions on top of CDSE. But I have two quick examples. One a bit larger scale is the CAP monitoring, right? And particularly Synergize is involved in there. But we're using the Sentinel data and something that we call area monitoring to do compliance checks for the Common Agricultural Policy. And there, instead of sending out people into the field at country scale and operationally running on CDSE, we have services with traffic light systems which allow us to try and identify if what the claims that are coming in from the farmers correspond to the reality of what we're seeing on the ground. And that's an example of something that's running at very large scale. We're almost at the continent scale across Europe, implemented by different operators for each different country. But I also wanted to talk about a smaller example. There's a company that's well known in the field of EO called Brockman Consult. They're an SME. There are about 40 people working there. And they heavily use CDSE now instead of their own infrastructure. And there they're developing services to analyze Sentinel data, to build data cubes, but they're also producers for the Copernicus Land Monitoring Service. So they're making lake water quality products and burnt area products at the European scale. And they actually chose to run it on CDSE rather than on their own premises because of the advantages there. The difficulty that they raise, though, is still, again, that they need different data sources and the interoperability needs to be there. I liked your example with the rangers because what I see is missing, or what we should focus on, is to build the tools that allow people to prototype really quickly, to do demos before building the full scale. And there we need to invest a little bit more on these tools.
Okay, thank you. Thank you very much. We thank the organizers for having us on the stage. Before we yield the stage. We have still 30 seconds. I saw a very interesting question about how we can deal with regulatory and security concerns of integrating Earth observation data from multiple constellations. Stefan, would you like to?
Multi-constellation of, sorry, I didn't see the question.
It's a national, multiple national and European constellations.
Okay, it's a big topic right now, and we're looking at that. Of course, when we look about global data set, we are normally, you will see with Copernicus and with the Destiny that we're open and we're trying to provide that. Of course, as more you go to the local part, as more sensitive information is getting in. But that's why we're also believing to build then local tuned solutions, because there will be different requirements, there will be different things. It might sometimes is personal related information, sometimes it's health information. So it's better than for the local implementer then also to decide on that level and not dictate something from the top. So for me, there was a discussion, actually the question on one standard or one interface, and that is kind, yeah, it's a bit related to that one solution solving everything. We tried it in the OGC days 10 years ago, tried to build an interface sorting all data. It didn't work. It became very complex. You don't want to work with that one. Okay,
now I have to interrupt you. I invite everybody to ask questions to our panelists over coffee, over snacks. Thank you so much. Thank you for being here, for taking time to answer the questions. I think it was very, very interesting.